Okay, so here we have a typical load cell. This is a S-style load cell for 50 pounds. Alright, so it's rated at 50 pounds. And to work this, we need an external power supply, so we need a 10 volt power supply. And so the way that we're going to wire this up is we're going to use the Redlion Controller to display the weight. And so use the terminal blocks here. So there should be on the back side of the terminal block, there should be two spares over here on the left side of the controller. And so we're going to wire those. Okay, make sure you maintain the color. And then on the power supply, on these connections here, these unscrew a little bit and there's a hole down in there. So what you want to do is take the wire, set the wire down through the wire. Again, don't use the big 16 gauge, just a 20 gauge or 18 gauge wire maximum, and stick it in the hole there and just tighten these up. So we're going to tighten these two connectors up. And I bumped my voltage there. We want to set the voltage with the meter, so make sure you use the meter to set the voltage and then don't bump it after you've set it. And then notice the current meter. Now this thing, if you turn the current knob all the way down, the voltage is going to drop some and the CC light comes on. Alright, so notice my voltage has dropped to 4.8 volts and the constant current light has come on. Alright, the circuit is wired correctly, but I need a little bit more current than the current limiting knob is letting. So don't just crank this all the way up, just turn this current knob just a little bit more until you see this constant voltage light come on and it return to your voltage setting that you had. So we've got 10 volts feeding in here through the terminal block. So coming in here, we've got our positive and negative 10 volts. Then we've wired up the load cell. Alright, so I'm not using any alligator clips here at all for this connection. So I've wired up my power to the load cell, my bridge of my load cell. And then I've got connections here, 11 and 12. So the green is wired to 12, the white is wired to 11. Now before we do this, we were asked to actually measure the voltage, so that's the only thing I'm using the meter, the alligator clip on the meter here to kind of measure the voltage. So here's the load cell and there's nothing on it, and the meter is reading, it's bouncing around right now for some reason here, probably, because I haven't connected. So I'm going to connect this other one so you can see that it's reading, the display is reading about 0.48 millivolts. So it's reading 0.48 millivolts with nothing on the load cell. Okay. So now I'm going to see if I can get those to stay there for a minute. I'm going to take a weight. Now we've pre-measured this weight. You can see I've marked on this weight that it actually claims it's 5 pounds, but it turns out it's closer to about 4.9 pounds. So it's marked on the weight there, 4.91 pounds, and I'm going to stick this 4.91 on there, and you can see now that the voltage there is about 3.4 volts. Okay. So 3.4 millivolts is the voltage with this weight sitting on top. So notice I'm not pressing down on the weight, I'm just trying to hold the weight here. I'm just holding the weight so that it doesn't fluctuate, but I'm not adding any extra weight on there. So I'm just getting the weight of the on the cell. Okay, so now we've measured this load cell values in millivolts. Okay, so we've measured this with 4.91 pounds on it, and with 0 pounds. So 4.91 pounds, I measured 3.40 millivolts. And with no weight on it at all, it measured measured 0.4, a positive 0.4. So I use my slope calculation. I do my slope calculation. I have my maximum pounds minus minimum pounds divided by maximum voltage divided by minimum voltage, and that gives me a slope of 1.6367 pounds per millivolt. Remember, that's 5 significant digits. I then calculate my intercept. My equation for the intercept is B is equal to Y1 minus M times X1. That's X1 right there. So it's 0 pounds minus the M that I calculated up above, which is the 1.6376 pounds per millivolt, times the millivolts. With the X1 millivolts was positive 0.4 volts, 0.4 millivolts, positive 0.4 millivolts. So notice the millivolts cancel and I'm left with pounds. So the units of your B turn out to be pounds, because that's what my Y value units are, is pounds. And so I get an answer there of negative, because with no weight applied, I had a positive value. So effectively, I need to subtract that value. So that value is the 0.4 times the M value, which gives me a B of minus 0.65467 pounds. Okay. So now to program the Redlion controller, the Redlion controller is designed to run from 0 millivolts up to 50 millivolts. If we set it at that, up to 50 millivolts, which is what the setting we're going to use. So we have to know, well, if I had 0 millivolts, what would be the weight? So I stick that in my equation. So I have my Y, and my pounds is equal to 1.637 pounds per millivolt times however many millivolts. And so the first question is at 0 millivolts. So I multiply that, and I'm basically left with my slope, my intercept, which is this minus 0.65 and some change. Then, since this thing can go all the way up to 50 millivolts, I have to say, well, what would be the millivolts? If the millivolts was all the way up to 50, what would be the weight in pounds? And so we stick that again in our equation, 1.637 pounds per millivolt times 50 millivolts, subtract off the B term, minus 0.65, and that gives me a result here of 81.18 pounds. Okay, so if the load cell was going to put the maximum of 50 millivolts for my scale I'm using, which is 0 to 50 millivolts, then the load cell would actually be weighing 81, a weight would have, it'd be telling me there's a weight on it of 81 pounds. Now technically this particular load cell is only rated for 50 pounds, all right, but remember, load cells should not output 50 millivolts. It should be something below that. And I've got my voltage set to 10 volts, which is maybe a little bit low. Sometimes they use 12 volts, which would make the voltage, the output voltage, a little bit higher. All right, but if you make the voltage too high, you can also damage your load cell. So we're using 10 volts. All right, so to program the Redlion controller, then, what we want to do is we want to come in here. We're going to press the P button. Press and hold the P button. Just press and hold until you see the control words show up, CTRL. And then press P again. So you press and hold until you see control, and then when you see control, press P till you see configure, CNFP, and then press it says no, press up for yes, or actually it goes to the input configure, and that's what we're configuring is the input, so just press P now, and then we're going to set the type, so we use the up or down arrows, and we want to set the type to 0.05 U, which is technically a V, which is 50 millivolts. Okay, so I'm setting the range from 0 to 50 millivolts. So it's 0.05. I'm going to press the P again, and I'm going to select how many decimal points you want. So I can have 0 decimal points, 1 decimal point, 2 decimal point, 3 decimal points. I'm going to choose 2 decimal points. And then I'm going to, the filter just kind of does an average of 5 values. So it smooths the fluctuations out a little bit. The band, we'll just leave that at 1. Then the shift, we'll just leave that at 0. Now here's the key one, display. So display 1, so we're going to set display 1 to be, if there's 0 millivolts, how much should you be weighing? Alright, so that's why we did this calculation. So it's 0 millivolts times my slope M minus my B gives me a display value of minus 0.65. Now I can only do out to 2 decimal points. So you see I have the display set to 0.65. And then I'm going to press the P again. And now that's the second value we did at maximum. So at maximum, which was 50 millivolts, we took 50 millivolts times our slope, 1.6367, minus the intercept, minus 0.65, and that gave us that 81.18. If you go to just 2 decimal places, which is all I can do, 81.18 pounds. And so now you can see I've got 81.18 pounds. And so what I'm going to do here now, right, we've got no, then the other settings, we press P to finish programming it. We have to come through here, press P. So I'm going to press P. This is a low set point for if you're trying to add features into this. You have a low set point and a high set point. We're really not using those, so we don't care what those are. And then some other user settings, we're just going to press P to get through all of that. Okay, until we get back to CNFP and end it. So now the load cell is ready to, the Redlion controller is going to display our weight. Now notice if the load cell is laying flat, it's not really proper. These load cells are designed so that they're like vertical to have the pressure on them. So the readings I took were when it was vertical like this. So if you notice here, it bounces around a little bit, but right now there's no weight on the load cell. And then you can see that it's reading 0.0 pounds and a little bit of change there. Okay, so we can see that it's reading 0.0. Now if I take my test weight then and set it on here, so we set the test weight on here, and you can see, right, remember this test weight I said weighs about 4.91 pounds, and so you can see it's about 4.9 pounds if I can hold it steady. So it bounces around there a little bit, but 4.9 to 5 pounds is displaying on there. So I've got the weight on here. It's weighing that weight. If I take it off, it should be giving me 0. Okay. So you can see it's actually a little bit high now. I think it's probably because I bumped my voltage earlier. So it's actually reading slightly high right there, about 0.09. So if I actually go back and reprogram it a little bit, I'm going to lower that display. I don't need these clips anymore. So I'm going to press and hold the P button till I see control show up. Okay, so I press and hold till I see control, and then I just press P to configure, C and F. Press up, get to inputs, configure the input, and I'm just going to subtract off of my negative here. I'm just going to subtract that off a little bit. So I'm going to subtract off about 0.9 of those. Alright, so I'm basically adjusting my intercept just a little bit. And I'm not going to change anything else. And I'm going to press P through here till I get back through all the settings. And now you see it's reading perfectly 0, which is really what it should be. Alright, so I think I bumped my voltage and then that changed my calculations a little bit. Alright, I should have used my meter to just reset it. Alright, and also notice it's real sensitive if you bump it a little bit. Okay, or put your finger on it, it weighs. But so now it's weighing 0 with nothing on it. And then I take my weight and I set my weight on here. And again, I'm just using my fingers to hold it up, but not letting it move. And you can see it's reading like 4.9. Okay, if I get it set and hold it just right, 4.9, 4.91, 4.89, something like that. So that is configuring the Redlion controller for a 50-pound load cell.